Sample problem 3.5 reads, ammonium carbonate, a white solid that decompresses on warming, is a component of baking powder. A part, how many formula units are in 41.6 grams of ammonium carbonate? And then B part says, how many oxygen atoms are in this sample? So again, this is going to be one of those conversion type problems. So we always start with writing down what we know. So we're going to do A part first, obviously. It says that we have 41.6 grams of ammonium carbonate. And again, just like the last problem, they do not give us the molecular formula for ammonium carbonate. So it's really important that you look over that table in Chapter 2 that lists the polyatomic ions. You just have to memorize that table, because a lot of these problems, and especially when you get to the exam, they're not going to give you the formula. You have to be able to derive the formula from the name. So ammonium, that is a polyatomic ion with the formula NH4 with a +1 charge. And I know I'm going to have two of those because carbonate is a polyatomic ion with a CO3 as its formula, and it has a -2 charge. And remember, we have to combine the ions together so that the sum of their charges equals 0. So with the NH4 having a +1 charge, I know I've got to have two of those. That would be 2 times +1 to counteract the -2 charge on the 1 carbonate ion. All right, and then they're asking for the number of formula units of the ammonium. So equals question mark. Now remember, this is the key here. We know we're going to have to use Avogadro's number, so let me go ahead and write it down. They're asking for the number of something, so that's 6.022 times 10 to the 23 entities per mole. And now if you'll notice, we have grams. Avogadro's number converts from moles to entities. So I'm obviously going to have to use another conversion factor that will get me from grams to moles. And remember, we've talked about it numerous times at this point. That will be the molecular mass, the molar mass from the periodic table. So I'm gonna type that in my calculator. I know that I have 2 nitrogens, right? This little 2 outside my parentheses tells me I have 2 nitrogens. So I'm going to have 2 times 14.01, which is the molar mass of nitrogen, plus I've got 2 times 4 hydrogens. So that means I've got 8 hydrogens. So 8 times 1.008, plus I have 1 carbon, so that's 12.01, plus I have 3 oxygens. So 3 times 16 equals. Now let me go ahead and fill in my T here. I've got grams in the top, so I've got to have grams in the bottom. And my molar mass was 96.094 grams in 1 mole of the NH4, 2 of those, CO3 with a 2 minus charge. Now let me check my units here. I've got grams divided by grams. That's going to cancel. I'm going to be left in moles. Now let me type this in my calculator and see what I get. I've got 41.6 divided by 96.094 equals, I have 0.4329 moles of ammonium carbonate. I gotta fix that. NH4, I got 2 of those, CO3. Alright, so let me see now. I'm going to rewrite my moles down here so I can set up another T. 4329 moles. NH4, 2, CO3. And Avogadro's number tells me that in 1 mole of anything, right, and I'm talking about ammonium carbonate here, there's 6.022 times 10 to the 23 entities, or since I'm talking about my ammonium carbonate, I'm going to write the formula there for it. And let's check our units. I've got moles divided by moles. They're going to cancel out. And let's see what our answer is going to be. So that number times Avogadro's number. And I got 2.61 times 10 to the 23 NH4, and I didn't put my 4 there. Let me put that there so I don't confuse you. 2 CO3 formula units for A part. B part says how many oxygen atoms do we have. So I know, I'm going to start another T here. I know that I have 2.61 times 10 to the 23 ammonium carbonates. So how can I figure out from that information, because that's the last piece of information I got to ask myself, what conversion factor do I have that will get me from ammonium carbonates to oxygen? And I'm kind of highlighting it here with my laser pointer, right? The chemical formula can also be used as a conversion factor. If I'm just looking at this chemical formula, for every 1 ammonium carbonate, I have 3 oxygens, right? That subscript tells me I have 3 oxygens. So I'm going to use that as my conversion factor. For every 1 ammonium carbonate, I have 3 oxygen atoms. That's not 30, that's an O, that's the symbol for oxygen. So let's do our units. I've got that canceling with that, and I'm going to be left with units of oxygen atoms. And I need a little more room there. I don't have enough room. Equals, all right, what does that equal? So that number times 3, I have 7.82 times 10 to the 23 oxygen atoms out of the 2.61 times 10 to the 23 ammonium carbonates. Now, I know that kind of looks a little weird, right? This number being larger than the number of formula units we had up here for our formula. But it should be, right? Because for every 1 of these ammonium carbonates, we have 3 oxygens, right? So this should be a bigger number, and it is.